Properties in Python provide a really clever way to create attributes that look exactly like normal variables on the outside, but secretly execute code on the inside. When you access a property, you don't use parentheses like you would with a standard function call. You simply type the object.attribute, just like this tracker.calories line right here. This allows developers to add things like data validation, perform dynamic calculations, or control access to private data, all without changing how the user actually interacts with your code. To really understand this intuitively, consider a fitness tracker on your wrist. When you look at the screen and see 847 calories, that specific number isn't just stored away in some static file. Instead, it is calculated fresh the exact moment you glance at it. Behind the scenes, the device dynamically takes your step count, your current heart rate, your weight, and the time elapsed to produce that result. You don't have to press a calculate button, you simply read the computed value instantly. In Python terms, that calories display is a computed attribute, what we call a property. Python uses specific keyword called decorators to define how these properties behave. They act as signals to intercept how an attribute is handled. Let's look at the three primary ones here in this table. The first is the property decorator. This is the most common one and it makes a method readable like a standard attribute. It triggers automatically when you read a value. Next, we have the attribute.setter. This intercepts the act of assigning a new value, which is incredibly useful for validating data before saving it. It's called when you set a value with an equal sign. Finally, there is the attribute.deleter, which intercepts the deletion of an attribute, triggered when you use the del command. So the core takeaway here is that properties let you compute data on the fly, while keeping the syntax incredibly simple for the person using your code. We'll see next how this creates a clean separation between a simple outside world interface and the complex inside logic, much like reading the simple gauges on a car dashboard while a complex engine runs underneath.
Let's build on what we just learned about properties. The core principle here is that the outside world sees a clean, simple variable, while the inside of the class has full control over what happens with that data. Think about driving a car. When you are the driver, you just look at your dashboard. The dashboard shows you simple numbers, your speed, your fuel level, and your engine temperature. As the driver, you simply read these values. However, behind the scenes, the speed is actually being computed from wheel sensors every millisecond. The engine temperature is constantly being evaluated. The car checks if it exceeds 110 degrees Celsius just to decide whether to display a simple hot or normal. Properties allow your Python objects to present simple values on the outside while performing all of this complex calculation and checking in the background. Let's look at a professional environment, like an e-commerce pricing engine on Amazon or Myntra. A product class might store raw data like a base price and a discount percentage. However, the selling price the customer sees is actually a property. It is calculated fresh every single time from that base price and discount to ensure it is always accurate. Furthermore, we can use a setter to validate changes. If someone tries to update the discount, the setter can check if that value is within a legal range, like between 0 and 70%, before allowing it to be saved. This exact pattern is fundamental to major software tools like SQLAlchemy, which is a database toolkit used by platforms like Reddit. When a user types something like user.email, it looks like a simple text lookup. In reality, SQLAlchemy's property system kicks in to check a local cache, communicate with a remote database, and convert the data types. The developer gets a clean, simple experience, while the underlying engine handles all the heavy lifting. Let's visually summarize these decorators before moving into the actual code. We see the three-part structure here at the bottom. First, the property decorator acts as the getter, making the method readable just like an attribute. Next, the name.setter intercepts any assignment, allowing you to add that validation we just talked about. Finally, the name.deleter intercepts the deletion command. The ultimate takeaway to remember is this. While the outside world simply sees what looks like a variable, What actually happens is a function runs secretly in the background to give you full control. Let's examine a concrete implementation of these concepts using a product class designed for an e-commerce platform.
Let's examine a concrete implementation of these concepts using a product class designed for an e-commerce platform. In the initialization method, the class sets up private attributes using a double underscore like self.__ base price and self.__ stock quantity. This effectively hides them from direct access from outside the class, keeping our core data safe. The first property defined is selling price. This is a read-only property because it only has an @property decorator and no setter attached to it. The calculation logic is straightforward. It takes the hidden base price, calculates the discount amount, and subtracts it to return the final price. Because there is no setter, a user cannot manually change the selling price. It must be changed by adjusting the base price or the discount percentage. The second property is stock status, which provides a human-readable label. It checks the internal stock quantity and returns out of stock if it is 0, only X left if it is 5 or less, and in stock otherwise. This automatically transforms a raw number into a useful business insight. Next, the class defines the discount percent. This includes both a getter and a setter. The setter takes a value and first uses an instance check to ensure the input is a number. If not, it raises a type error. Then it checks if the value is strictly between 0 and 70. If the value is outside this range, it raises a value error. Only if both checks pass is the private attribute updated. A similar protective logic is applied to the stock quantity setter. It ensures that the stock cannot be a negative number, as negative physical stock is impossible. This protects the absolute integrity of our inventory data. When we test this code, we create a Banarasi silk sari with a base price of 8500. Initially, the selling price is 8500 because the discount is 0. When we set the discount percent to 20, the setter runs, validates the number and updates the state. Now accessing the selling price automatically returns 6800. If we attempt invalid operations like setting the discount to 85, giving a negative stock, or trying to write directly to the read-only selling price, the code triggers the specific errors we defined. The core takeaway here is that properties act as intelligent gatekeepers, ensuring your object's internal state remains valid and secure while providing a clean interface to the outside world. Now let's explore why using this property approach is often superior to writing traditional getter and setter methods.
To solidify this understanding, let's explore these three key points. First, the interface advantage. The benefit of a property over a traditional method like getPrice is purely about how you interact with the object. It gives you the clean, easy-to-read syntax of a property, allowing the object to be used naturally as if it were just plain data. However, behind that simple interface, it retains the full power of a method. It's incredibly natural to use while still doing heavy lifting in the background. Second, we can create read-only properties. If you define a property without a setter, you create an attribute that can be read but not written to. This is perfect for calculated values like a total price or a system status. It ensures these values remain protected from manual changes, so no one can accidentally overwrite your logic. Third, let's look at some real estate app examples. If you are modeling this house, you wouldn't store every single detail in a database. Instead, you'd use properties for things like the price per square foot or the years since renovation, which are instantly calculated from other fundamental data points whenever you ask for them. So here is the professional rule of thumb for your own code. Use a setter if the data needs validation on the way in. Use a getter property if the data needs to be calculated on the way out. And use only a getter if the data should be completely protected from external changes. As a final exercise, imagine building a circle class for a CAD tool. You only need to store one piece of actual data, the radius. To protect it, you would use a setter for the radius. Look at the logic here. It validates that the radius is greater than 0, ensuring it is mathematically valid. Next, you create read-only properties for area, circumference, and diameter. They don't store values, they just do the math using the radius. Finally, a size category property returns small, medium, or large purely based on what that radius is. By following this structure, you get auto-consistent updates. As soon as you change the radius slider, the circle itself adjusts, and instantly, every other measurement updates automatically and stays perfectly consistent. This is the ultimate payoff. By strategically using properties and setters, you create objects that are wonderful for others to use because they look like simple data. But under the hood, they are actually smart objects that validate their own state and flexibly calculate their own values. You now have the patterns needed to build truly robust, professional classes in your own software projects.